Let's say that you have a floor lamp in your living room. To turn this floor lamp on, you plug it into the wall and flip the switch and the lamp turns on. Now, what you take in your hand and plug into the wall outlet is a cable. Inside this cable, there are two wires. One of these wires is what we call a hot wire, and the other one is what we call a neutral wire. When you plug the cable into the outlet, the electricity flows through the hot wire and travels all the way to the switch. It stays there as long as the switch is open, but as soon as you press the switch, the electricity starts to flow to the lamp. At the bottom of the lamp, there is one input and one output. The electricity goes into the lamp via the input and comes out of the lamp via the output. The output of the lamp is connected to the neutral wire. So the electricity uses this neutral wire to go all the way back to the outlet. And when this happens, we have a complete circuit and the lamp turns on. So the electricity goes from the outlet to the hot wire and then to the switch and then to the lamp and then comes back to the outlet through the neutral wire. Now this lamp here slows the electricity down. This slowdown is what we call resistance. Now, this slowdown or resistance is very important because it controls how much electricity or how much current flows within the circuit. For example, in a circuit like this, the normal current rate can be about 1 ampere. So as long as we have this lamp within the circuit, we can slow down the flow of the electricity, and by doing this, we can keep it in control and in about 1 ampere range. But now let's remove this lamp. What happens when I do this? Well, if I remove the lamp, there won't be anything else within the circuit that can slow down the electricity and keep it in control. That means when I remove the lamp, I remove the resistance, which means resistance goes to zero. And when resistance goes to zero, current goes extremely high in a very short period of time, like going from 1 ampere to 1,000 ampere. And this is what we call a short circuit. So a short circuit happens when the source of control in a circuit is gone. And when that happens, there is nothing else within the circuit that can control the current. The resistance goes to zero, the current goes very, very high, like going from 1 ampere to 1,000 ampere, and that is basically what we call a short circuit. Very simple, right? Now, what happens when a short circuit happens? Well, when a short circuit happens, as I mentioned, the current goes extremely high. When the current goes extremely high, the temperature will also go extremely high as well. And when that happens, a lot of other bad things can happen as well. For example, the high temperature can melt the wires or can even start a fire. In big industrial systems, short circuit can cause big explosion or even damage to personnel. Now, if you zoom out of the electrical engineering world and look at other things in the world around us, you can realize a short circuit just follows the rules of physics, and that is, when you remove the main source of control in anything fast, there is always a spark of things going out of control extremely fast. For example, in a big city, traffic lights control the flow of cars, right? Now, if all of a sudden, all of these traffic lights stop working, things can get out of control and hundreds of cars around the city can crash into each other in a short period of time, right? Or to give you another example, if in a big city, all of a sudden you remove the police and the government, which are the source of control in a city, in a short period of time, you'll see a very extreme spike of bad people doing bad things. Why? Because there's nothing that can control these bad people and they can do whatever they want, right? Now, going back to the electrical engineering world, you see that a short circuit is nothing more than removing the source of control for the electricity. For example, in our simple but practical circuit, the lamp is the source of control, and as soon as you remove that, there was nothing that could control the resistance. The resistance went to zero, current went very high, and following that, the temperature also went very high. So electricity is good, but it is good as long as we can keep it under control. And as soon as it gets out of control, bad things can start to happen. Now, as I mentioned, short circuits are dangerous, but the question is there anything that can keep the circuit safe when a short circuit happens? I'll answer this question next, but before doing that, if you're an operations manager and want to train your team of engineers or technicians on any topic related to electrical engineering or industrial automation, and you need a custom training based on the equipment that you have in your factory, you can check out realparts.com/custom training. On this page, you can fill out the form and answer a few short questions, and if there is a fit, you'll be provided with a link to book a short call with our team. So if you need custom technical training for your team, check out realparts.com/custom training. You can find the link in the video description as well. Okay, let's go back to the video and answer the question we raised. Is there any way we can protect a circuit against a short circuit? The answer is yes. For that purpose, we can use a fuse. A fuse is just a simple electrical component like this one you can see here. Inside a fuse, there is a very thin metal wire. If too much electricity passes through this thin wire, the temperature goes very high and the wire burns. Now, let's go back to the circuit again and add a fuse here right before the switch. Now, when the lamp is in the circuit, if I press the switch, the electricity flows to the lamp from one side and comes out of the lamp from the other side and goes back to the outlet through the neutral wire. Now, if I remove this lamp, this source of control, you know what happens next, right? Yes, when the source of control is gone, the resistance goes to 0 and then the current goes to a 1000 ampere range, which is what we call a short circuit. But this time there is a difference. This time I have a fuse here. When the fuse is here and the current gets to a 1000 ampere range, this huge amount of current passes through the thin wire within the fuse. And as I mentioned before, high current means high temperature. So the high temperature burns the thin wire within the fuse. And when that happens, the circuit gets disconnected. And that is basically how a fuse can protect the circuit when a short circuit happens. So you saw what happened. Lamp is removed. Source of control for the current is gone. Resistance goes to 0. Current spikes to a 1000 ampere, but this time, since we have this fuse here, the thin wire within the fuse burns, cuts off the circuit, and cuts the electricity. So there you have it. Now you know what a short circuit is, how it happens, and how you can protect a circuit against a short circuit. As I mentioned at the start of this video, if you're an operations manager and want to train your team of engineers and technicians on any specific topic related to electrical engineering or industrial automation, please feel free to check out realparts.com/custom training and fill out the form. This will take you less than a minute, and if there is a match, you will be provided with a link to book a call with our team to discuss how we can help you with a customized training for your team. Thanks again for watching this video, and I'll see you in the next video.